For instance, I'm asking you to find out which ones are scalars and which ones are vectors. Your multiple choice might say all of the following are scalars except what, or all of the following are vectors except which one. And you should know what scalars and what vectors, which ones are which. Things like energy, like 12 joules of energy, it doesn't make sense to have a direction. You don't have 12 joules of potential energy north, right? Because that doesn't make sense, so that must be a scalar. You know it's a vector, for instance, if it could have direction. A vector, such as momentum, you can have momentum to the left, you can have momentum to the right. Your momentum is dependent on direction. That makes it a vector. What about a force? Can a force have direction? Can you push something to the left or to the right? Yes, that makes it a vector. How about time? When you measure something in seconds, does it matter if it's to the left or to the right? Does that make sense? No, so that's a scalar. Friction, can you have friction to the left or to the right? Yes, so friction is a vector. I want to give you some time now to see what you can do with number 2, 3, and 4. Those examples look similar to examples that we did yesterday and the previous day. I want to see if you can remember how to do it. And then after about, 5-10 minutes, I'll go over the answers to those, okay? You can ask me, you can ask Ms. Grissom, you can work with each other, you can use your notes. My goal is that you understand how to do these types of problems today and Monday. All right? So go ahead and try 2 through 4. Okay, so here we go. You can see what scalars, what vectors are. Again, vectors, remember, would have direction. If it makes sense that it has a direction, it's a vector. If it doesn't make sense, like time, for instance, when you're measuring something in seconds, direction doesn't make sense, it's a scalar. Okay? For number 2, this one, similar to, I think the example was Abigail and somebody else, reaction time. And as mentioned before, if you have someone that has twice the reaction time, if it takes them twice as long, an object will fall 4 times as far. Because doubling the time, if the time is squared, that'll make it fall 4 times further. What if you triple the time? If you drop something and you triple the time, the distance would be 9 times as great. Well, here, we're looking for, if Rick catches it at 64 centimeters, where does Aaron catch it? Now, Aaron's twice as fast. It doesn't take twice the time, it takes half the time. What is 1/2 squared? 1/4. Yeah, so if 2 squared is 4, then 1/2 is 1/4. All right, so that's why 1/4 is 16 centimeters. So Aaron, who is twice as fast, will catch it in a distance that is 1/4 as great. Number 3, we talked about a kilowatt hour yesterday. A kilowatt hour, well, first of all, 100 watts, a watt is a joule per second. Power is energy per second. So 100 watts is the same thing as 100 joules per second. Times 1 hour, because we're trying to find out what a kilowatt hour, an hour is 60 minutes times 60 seconds, or 3,600 seconds. So the total energy used by 100 watts times 3,600 seconds would give you this 360,000 joules. Well, a kilowatt, which is 1,000 watts for an hour, would give you 3.6 times 10 to the 6 joules. It would be 10 times bigger, meaning that you use 1/10 of a kilowatt hour. And the question is, if it's 10 cents per kilowatt hour, and you use 1/10 of a kilowatt, then the cost would only take 1 cent. Yes?
Couldn't you just take 10 cents per 100 watts per hour and just take off the 2 zeros?
When it's 1 hour in a kilowatt hour, yes you can, because 100 watts is the same thing as 0.1 kilowatts. The reason I showed you this method is, for example, the numbers could be different. For instance, if instead of 1 hour, if it said 40 minutes, the only thing you would need to change is right here where it says 60 minutes, you would change it to 40 minutes. But the same method applies. Okay? Yes, good observation.
Can you go over that one more time?
Sure can, I'll do. So first of all, I want to find out how much energy is used. 100 watts means 100 joules per second. And it says that that occurs, how much money do you save by turning off 100 watts for 1 hour? 100 watts, that's 100 joules per second, so I multiply by the number of seconds. 60 minutes times 60 seconds is 3,600 seconds in 1 hour. Seconds would cancel out, leaving you, this is the total energy used or saved by turning off that light bulb for 1 hour. Now,
I thought it was 3,600.
3,600 seconds times 100 joules per second will give you 360 joules. That's how much energy you save by turning off that light for 1 hour. Now, in terms of kilowatt hours, which is 3.6 times 10 to the 6th, this is 3.6 times 10 to the 5th. When you divide to cancel out the joules and you get kilowatt hours, you see that it takes 0.1 kilowatt hours. And at the rate of 10 cents per kilowatt hour, that equals 1 cent. Now, when we go over all of the review, between today and Monday and things, we can do more examples of whatever problems that you want to see. If for some reason you need to see this again, there's a video that's being recorded and this key is posted. Okay? So this key is posted. The video is going to be available to you, so you have lots of review. And this review is a very good, close, accurate depiction of what the 20 multiple choice would look like. Things are scrambled around, numbers might be a little bit different, but essentially it's the same thing, but it's in multiple choice form. All right? Similar one to yesterday. 40 newtons is needed to keep the object sliding across at a constant velocity. Going at a constant velocity, just like yesterday, means that forces cancel out. There's no acceleration when there's a constant velocity. No acceleration means that there's no change of velocity. The force you're pushing with equals the force of friction. The force of friction, your fun equation, is right here. So if your force of friction is 40 newtons, and you're looking for the coefficient, your normal force is equal to weight down and the normal force up. We know that they cancel out because otherwise the object would fall through the surface or fly off of the surface. You're not pushing down on it, you're not pulling up on it. So here the weight and normal force are the same. So 40 newtons divided by 10 times 9.8, you get 0.41 or about 0.4 as your coefficient of friction. Okay. Again, some of these, hopefully as you see more and more of these problems like we did yesterday and that we're doing today, you'll start to understand the process so that you can apply this to another problem that you can see on the exam in multiple choice form. At this time, I'd like you to try the next ones, try 5 through 8 over the next 5 to 10 minutes, and then we'll go over 5 through 8. Okay?
Yeah.
No.
Number 5.
Number 6, let me just throw this idea out there too. For number 6, if one person is walking 3 meters per second in this direction, the other person's approaching at 2 meters per second, how quickly are they approaching each other? 5 meters per second. If they started 100 meters apart and they met at 30 meters apart, what's the distance that they covered? 70. If you cover 70 meters at 5 meters per second, how many seconds does that take? 14. There you go. And there we are. Is this the mass that you got for the object?
Yeah.
Is it?
Yes.
Nice. Now, if you had 0.08 kilograms as your answer, would you know in multiple choice form that that's the same thing as 80 grams? How many grams are in a kilogram? 1,000. You move it 3 decimal places. So if you've got an answer of 500 grams, for instance, you should also know that's the same thing as 0.5 kilograms. When you have this summary sheet, which you're allowed to have, it has prefixes on it. You should probably look at this from time to time just to see what's available to you. Like you have these linear equations. You have the force of friction. You have momentum. You have these equations on this sheet. You just have to be able to know how to use them. Okay? Number 7. We had this example either yesterday or the day before. They all kind of run together a little bit. But remember, if you have to stop in half of the distance, and it's v squared, it's proportional to v squared, to get half the distance but it's squared, that squared gives you half. That is 0.707. That is the same thing as 70.7%, or about 71%. Let's say you wanted to stop in 1/3 the distance. What would we do differently? 1/3 the distance, take the square root of 1/3. Okay? So that's how they're related. Number 8, the cable rises and brings a mass of 80 kilograms up vertically. Is there any mention of an additional acceleration? No. So the tension is going to be equal to what force acting down? The mass times gravity, right? The weight. Now, if you did have an acceleration, the example we had yesterday, we accelerated the object up, which means you add that acceleration to gravity. What would you do if you accelerated something down? You would subtract. If something moves at a constant velocity, as this example was, you don't need to add or subtract acceleration. You're not given one. You just multiply by gravity. 80 times 9.8 gives you the tension in the rope or cord, string, whatever it happens to be, which comes out to 784 newtons. All right, and again, this key is posted in that classroom. Okay, Mr. Joe put that there for you all so that you can reference that when you need to, and also this video. For the next ones, I want you to try to get through number 9 and 10, and then that'll give me time to go over it. So we'll go over the first 10 today, the next 10 on Monday, or even if you're not going to be here Monday or don't have a chance to view it on Monday, you can still see the entire answer key that's already posted with explanations as to why those are the answers. Okay? All right. That's it. All right, so let's look at number 9. 9 is a conservation of momentum problem. You've got this freight car rolling with some velocity. So you've got momentum of the first car colliding with a stationary mass of 6,000. Stationary meaning what? It's not moving. So what's the momentum for that one? 0. So the first momentum, 12,000 times 3 meters per second, that gives you 36,000 kilogram meters per second. Colliding with something with no momentum. This is momentum before equals momentum after. When you have something that's conservation of whatever it is, that means you don't have any created or destroyed. It's the same before and after. The after momentum is the 12,000 kilogram car is moving at some velocity. That's what we're looking for. The 6,000 kilograms, which was initially at rest, is now rolling at 2.5 meters per second. If you can set it up, that's the hardest part. Then you just solve for your unknown, and that's where you get 1.75 meters per second. In number 10, the Wile E. Coyote one, remember we did a similar one to that yesterday. It's like a horizontal launch. You can simplify this equation. Well, you can simplify a couple of them. Y equals 1/2 gt squared, and x equals vx times t. Those are the only two you need for a horizontal launch.
Are those on the formula sheet?
This is on the formula sheet, which at the beginning velocity is 0. You're left with this, which is the same thing as y equals 1/2 gt squared. This equation is the same thing as velocity is distance over time. So, like the AP exam will tell you, it gives you this list of equations, but that doesn't mean that's all you could have to possibly use. Sometimes you can substitute things in and you can derive new equations from the information given here. So if you're not familiar with which equations are on here, always a great thing to look at. You don't have to memorize prefixes because they're on the front. You don't have to memorize constants because they're on the front. The basic equations are on the back. We're doing something called mechanics. That's what's in the left column. The first 3 are linear acceleration, they're these. Then you've got F equals ma. Then you've got the force of friction, momentum, impulse, kinetic energy, work, power. And you get the idea. Those are the ones that are on here. So if you're not sure, I encourage you to look at, you've probably got one of these. For horizontal launch, y, the distance up and down vertically, 1/2 gt squared. You want to first find the time. Then once you find the time, everything else just kind of falls into place. That's a joke, okay? Anyway, we'll work on that. So the time is about 3 seconds. Once you find out how long the object's in the air, in this case Wile E. Coyote, if he's running at 10 meters per second and you're in the air for 3 seconds, you will have covered 30 meters. So he is now 30 meters out from where he landed from the base of the cliff from where he fell. So again, you would have a multiple choice similar to this, probably with different numbers, but very similar, okay? So I would look over the first 10 multiple choice that we talked about today, and also try the next 10 multiple choice, remembering that there is a key posted so that you can always go and check your answers. And if you have more questions, please come in Monday with questions and we can go over whatever ones you want to out of those 20. I'll probably focus on the 11 through 20 and any other questions you might have. Okay? All right. Thank you, and that's it.